Hello everyone. Today we are going to be doing some problem session number two. We will continue from where we left off yesterday, and let's continue with our fourth question. So we are here in this question. We are asked to find the some values on this graph fx, and we need to sketch the graph draw the graph of f and determine the dominant range of f. Let's try to draw the graph of f on xy coordinates first. So we have it is behaving, the function is behaving when x is smaller than 0, it's behaving like this line x plus 2 line. So for the value, for the x equals 0 value, it gives us 2, but this needs to be empty because it is not actually taking that 2 value. For x equals 0 value, it's actually getting this x square, which is 0. So we have a value here, and for the this function, for the x which are smaller than 0, it is behaving like x plus 2. So when x is minus 2, it is crossing with the y-axis at this point, minus 2 point. So it is behaving like this line, but this point 2 point is not included because it doesn't have that 0 value in its domain. For this part, the 0 is included as a domain, but for the x square parabola, so we have 0. When you give 0, it is 0. When you give 2, it is 4. So we all know what x square parabola looks like. It looks like that. And for the value 2, it is it has a y value of 4, and it has this point. So for the values greater than that are greater than 2, it is behaving like 6 minus x. And 6 minus x, for example, when you give 2, it is also giving you a value of 4. So we can draw 6 minus x like so. We have 6 minus x. When you give 0, when you give 6 as a value, it is giving you the y value as a 0. So that's why it is intersecting with this x-axis at the value of 6. Starting from this point, it is intersecting with x-axis at the value of 6. So that is essentially our graph. For the calculations, let's calculate f equals minus 3 when f equals when x equals minus 3. It is essentially using this formula. So because x minus 3 is smaller than 0, so it is giving us the value of minus 1. And for the x equals 0, it has this formula, parabola formula. The value is 0. For the f equals 2, it is also dropping this this parabola. It is on this parabola. So for the x equals 2 equals 4, and for the 5, since 5 is greater than 2, it needs to be on this line. So it is 1, and domain and range. So as you can see from the graph, there is no point that we cannot use x when we talk about the domain. We have lots of x values, but there is no x value that we need to exclude from the domain. Here also you can see from the x smaller than 0, from 0 to 2, and from the x values greater than 2. So we are able to use all the x values. That's why the domain of function can be written as all real number set. For the range of the function, so when x goes to infinity, the function is going to minus infinity. When x goes to minus infinity, function is again going to minus infinity. The y value is going to are going to minus infinity, and the maximum value that this function can take is here. This is the top of the function. And 4, there is no value that can be greater than 4 according to this partially piecewise function. That's why the range starts from minus infinity to 4, and 4 is of course included. Continue with the question 5. it is asking us to find the inverse of this function, and then we need to prove that when the function itself is composed with the inverse of function, it will give us x, because if when composed with the inverse, any function when composed with the inverse, they will cancel each other, and you will end up with x. And at the end, we need to find the domain of f and domain of the inverse of f function. So let's get started. We have y equals 2x minus 3 divided by x plus 4. This can be rewritten as 2x plus 8 minus 11 over x plus 4, which can be rewritten as 2 parentheses x plus 4 minus 11 divided by x plus 4. These are canceling each other, so we will end up with 11 over x plus 4. So we need to leave this x alone so that we can take the inverse of the function. At the end, we will be swapping x with y and y with x. So we have, from here we have y minus 2 equals minus 11 over x plus 4, or x plus 4 equals minus 11 or plus 11 divided by 2 minus y. And at the end we have x equals 4, sorry, not 4, 11 over 2 minus y minus 4. And now we can swap x with y, y with x. Y equals 11 over 2 minus x minus 4. This is our the inverse function for the f minus 1, f to the minus 1. So then we need to prove when they are composed, we will end up with x. We have already inverse of fx function. When it is composed with fx function, it's basically taking fx as a parameter. So we have this function, it is taking this is inverse of fx, it is taking fx as a parameter. So this is essentially 11 over 2 minus 2x minus 3 divided by x plus 4 minus 4. So this is 11 over 2x plus 8 minus 2x plus 3 divided by x plus 4 minus 4. So these are canceling each other. These are cancelled each other. So we have 11 over x plus 4 in the denominator. You can convert it and you will end up with x plus 4 divided by 11. So x plus 4 you, divided by 11, you have 11 here, times 11 minus 4. So these are also cancelled, and 4 minus 4 0, and you will end up with x, which proves that when the functions are composed, the function with the inverse of it composed, you will end up with x. It is asking us, for example, specific to compose the function itself with the inverses, but the order does not matter. You can f taking f minus 1 as a parameter, or f minus 1 taking fx as a parameter. It doesn't matter. So you will end up always with x itself. So we have found our f minus 1 function, which is 11 to the minus x minus 4. Let's write it down here. So then we are asked to find the domain of those two functions. Let's clean this up. So we'll continue with finding the domain of those two functions. We have f function and f minus 1 function that we have already found. I would like to draw the graph of at least fx function so that we can see some uh, horizontal asymptote, vertical asymptotes regarding this function, because these asymptotic questions, finding horizontal and vertical asymptote in hyperbolas, this is not a parabola, this is a hyperbola, are frequently asked in the exams and in the quizzes. So let's simplify this fx. We have y equals 2 to the x plus 8 minus 11 over x plus 4, which can be written as 2 minus 11 over x plus 4 for the x. And when you try to draw the graph of this function, you have xy, and you have when x is 0, for example, this will be have value of minus 11 over 4, 8 minus 11 over 4, minus 3 over 4, which is the this point, for example, minus 3 over 4 when x is 0. The function crosses with the y-axis in this point, at this point, and when y equals 0, at which point the function crosses with the graph, not graph, with the x-axis. So we have essentially y must be 0. Then when y is 0, minus 2 equals minus 11 over x plus 4. So 2 equals 11 over x plus 4. 2x plus 8 equals 11. Then you will end up with 3 over 2. 3 over 2 as a x point. This function crosses x-axis with that point. So when the function itself, in order to find the horizontal and vertical asymptote, in order to find the horizontal asymptote first, you need to check the behavior of function when the function goes to plus or minus infinity. So this function, for example, when x goes to plus infinity, the denominator goes to infinity. 11 over infinity goes to 0, and so 2 minus 0 equals 0. So that's why you have a horizontal asymptote here, y equals to line. And when function goes to infinity, the y value is getting closer and closer, y equals 2, but it never reached this value. So, and you have a special case here. In the denominator you have x plus 4. That's why x being 4 cannot be used. X can never be 4 because it makes the function undefined. So that's why we also need to draw this x equals minus 4 line, because the function can never use that value, x equals minus 4 line. And when function reach, or when function gets closer and closer to uh, x minus 4, you can get closer and closer to minus 4 from this direction or this direction, from right or left. When you reach to the function, when you reach to x minus 4 from this direction, you have essentially, for example, minus 3.99999. So this, when you sum them up with the 4, you will end up with a very, very small positive number in the denominator. In the denominator, you have a very small positive number. When 11 is divided by that very small positive number, it goes to infinity. So if it was a very big number, it is going to 0. When it is very small number in the denominator, it is going to infinity. So 2 minus infinity is essentially going to minus infinity. So your function, when you reach from the right side, it's going to minus infinity. And when x goes to infinity, when x goes to minus 4, from right side, it's going to minus infinity. When x goes to infinity, it is getting closer and closer to y equals 2. So that's why you can draw graph like that. You have a graph like that, but this is only one portion of the graph, because you need to also use the x values for in this direction. Like, x equals minus 5 you can use for this graph, x equals minus 5, minus 6, minus 7, etc. So you need to also calculate, you need to also understand the behavior of function from this side. When x goes to, when x goes to minus infinity, when x goes to minus infinity, how this function behaves? You have essentially minus infinity. Assume that you put minus infinity as a parameter, input parameter, minus infinity plus 4, which results with minus infinity in the denominator. You have minus minus here, 2 plus 11 over infinity. 11 over infinity goes to 0, 2 plus 0 goes to 2. So you have function when you approach uh, to minus infinity, your function is going essentially your function is going essentially to 0, sorry, 2, in this direction. In this direction, when you approach minus infinity, your function is going to 2, but it never reaches to, it never touches to y equals 2. When you approach this x equals minus 4 from uh, left direction, you are essentially giving, for example, a minus 4 dot 0 0 0 0 1. So it will end up with very small negative number, and you have very small negative number in the denominator. You have minus here, or this can be written as plus because you have very small negative number. This negative will end up with plus. So you have a very small positive number now in the denominator, and that's why this will become infinity, and 2 plus infinity will go to infinity. So you can draw that graph as like so. When x goes to minus infinity, it is getting closer and closer to 2. When x getting closer and closer to minus 4 from this direction, from left direction, it's going to plus infinity. So you have two portions of this graph. So we have drawn our fx function, and for which values that you cannot use, when you look at this graph, which value of x you cannot use? Minus 4 value of x you cannot use. Any other value you can give. Going up to plus infinity, you can give. Going up to minus infinity, you can give. But this minus 4 value you cannot give. That's why domain of f equals real numbers minus 4. You need to remove minus 4 from real numbers, or this can also be rewritten as minus infinity to minus 4 combined by minus 4 to plus infinity. So for the domain of f minus 1, which is the inverse of f, we have this value. So essentially, you can also you cannot also give 2 as a input parameter because it makes the function undefined. But that is why apart from 2, you can give any other values. That's why from minus infinity to 2 combined by 2 to plus infinity is the domain of f, inverse of f, and I believe that will be enough. That is enough explanation for this problem. Let's continue with the next one. So for this problem, this is a basic logarithm exponential program. We are asked to find the x value. So 3 to the 2x minus 1 equals 3 to the 3. 2x minus 1 equals 3, x equals 2. So you can solve this problem by taking the logarithm of both sides for this formula also. When you take logarithm of with base 3, for example, when you take logarithm of both sides according to logarithm base 3, 3 to the 2x minus 1 equals logarithm 3 to the 27, which can be written as 3 to the 3. In the logarithm, we have learned a rule, a power rule, exponential rule, that is when you have an exponential in the inside of the logarithm, you can put that exponential value to the outside of the logarithm function. That's why you can write this formula as so: 2x minus 1 logarithm 3 to the 3 equals 3 logarithm 3 to the 3. So this is 1, this is 1. You will end up with x equals 2. And for this one, we can, since this is not something like 8, 16, 32, 64, etc., we need to we are required to take the logarithm of both sides to leave this x alone. So if you take logarithm according to base 2, logarithm of base 2 of 2 to the 3x minus 1 equals logarithm of base 2 of 7. And again, you can put this exponential outside of the logarithm, and logarithm of 2 to the 2 equals logarithm of 2 to the 7. Logarithm of 2 to 2 is 1. You will end up with logarithm of 3x minus 1 equals logarithm of 2 to the 8th. So logarithm of 2 base 2 of 7 plus 1 over 3, which is x, which is our x. You can also take, instead of using logarithm base 2, you can also use ln, for example. Logarithm of base a, you can also use, but I choose to use logarithm of base 2 because we had an exponential with 2, not with e in this example. So in this question, we are asked to find the root of this function. Okay, we can rewrite this function as 5 to the e to the x plus 6 equals 0. You can write this 6 as minus 2 to the minus 3, and you can write this e to the 2x as e to the x, e to the x. And then you can solve this problem using e to the x minus 3 times e to the x minus 2 equals 0. Essentially, what we have done is to separate two roots from each other. When you distribute these x's inside of the parentheses, you will end up with this, and this is this separated way of separated form of this function. So you have two roots, which makes this function 0. You have e to the x equals 3, e to the x equals 2. When you take the ln of both sides, ln e to the x equals ln 3. Essentially, you can put x outside, x equals ln 3, and for this one, also ln e to the x equals ln 2. You can take the ln e to the x equals ln 2. You can take x outside since this is an exponential exponent. X becomes ln 2. So you have two roots that solves the problem. In the next question, we are asked to find the k and then put the k and complete the population model and define the population after 8 hours. So we have okay, after 3 hours we are given the information that after 3 hours the population is 2000 when we give three as an input parameter, because this t represents the time. When we give t as an input parameter, we will end up with a function that has only one missing parameter, so that we can find k. P3 equals 800, e to the k 3 equals 2000. So we can simplify this one as so. When you divide by 4, 5, you have 2 here. So 2 times e to the 3k equals 5, e to the 3k equals 5 over 2. So you can now take the ln of both sides in order to leave this k alone and find the ln 5 over 2. uh, ln of e to the 3k equals ln of 5 over 2. 3k you can put to the side of the ln e. So ln e will be simplified. You will end up with 3k ln 5 over 2. K will be ln 5 over 2 divided by 3. So we have found our case, and the complete formula Pt equals 800 e to the ln 5 over 2 divided by 3 t, essentially. This is our complete formula. This is the answer to the first question. This is the answer to the second question. For the third question, find the population after 8 hours. We already know the key, and we need to just apply 8 as an input parameter to find the total population. 800 you have here, and e to the ln 5 over 2 divided by 3t. So when you give 8 as an input parameter, you will end up with 8 here. So I have just realized that this can further be simplified, because you have essentially 800 here, e as an exponent you at the base, and in the exponent you have ln, not ln 8. It is better to write that here. So let's say 800 e to the 8 over 3 times ln 5 over 2. So you have e here, you have ln here with multiplied by some constant. So you can put this 8 over 3 as an exponent inside of ln, and then you can simplify this e with ln. So let's do it. 800 e to the ln 5 over 2, which has an exponential value of 8 over 3. So you have exponential here, and in the exponent part you have ln here. So those are inverse of one another, so they will cancel each other. That's why you have 800 times 5 over 2, whose exponent is 8 over 3. This is the value. This is the answer to the third question. And we can also here also we can do the simplifications here for the function itself. For the second question, we can simply rewrite it as 800 e to the ln 5 over 2, whose exponent is 3 over 3. So these are simplified, ln and e canceling each other. So you will end up with here 800 5 over 2, whose exponent is 5 over 2 to the t over 3, which is the pt function. So for the next question, it is asking us to find the domain of this function and then to do the expansion of this logarithms. We have already learned how to we have already learned in the previous lectures how to expand logarithms when you have production, when you have multiplication or division or exponent rules inside of logarithms. So let's first determine the domain of this expression, then do the expansion. Ln you have simply x to the 3 multiplied by x minus 1 divided by x plus 2 to the 4 you have, and for this value you have spatial values. In this case you have ln, and inside of logarithm cannot be 0 or negative. So you need to take that into consideration. Inside of square root cannot be negative, so this cannot be smaller than 1, and the denominator cannot be 0, so this cannot be minus 2. So you have special values here, 0, 1, and minus 2. They are your special values. So according to those, you need to check the range. In the x-axis you have plus infinity. This is assuming that this is x-axis. You have plus infinity, minus infinity. You have 0, you have 1, you have minus 2. For the values, for the x values that are greater than 1, this is becoming positive, positive, positive. So there is no problem. You can use this range. You don't have any problem causing ln being negative or the square root instead of square root being negative or denominator being 0. So you can use this range without a problem. For the values between 0 and 1, so this will become negative. So that's why you cannot use this range. For the values between minus 2 and 0, so 0 for example, which makes the function logarithm of the inside of the logarithm 0, so you cannot use 0. Actually, for the value smaller than 1, you cannot use, because it always makes the inside of the square root negative. So that is why you cannot use, and you cannot use the value smaller than 1. So you cannot use here, you cannot use here. The only values that you can use are 1, starting from 1 going up to plus infinity. So that's why domain of the f is 1 going up to plus infinity. Going up to plus infinity. Sorry, that is not 1, because when you give 1, this function becomes 0, and inside of the logarithm cannot be 0. That's why 1, it is not included. So starting from 1, 1 is not included. Going up to plus infinity is your domain for this function. And let's do the expansion for the function itself. You have logarithm ln x to the 3 square root of x minus 1 divided by x plus 2 to the 4. So the multiplication can be written as addition when you put the outside of the logarithms, and the division can be written as the subtraction when you put the outside of the logarithm. So you will end up with ln x to the 3 plus ln square root of x minus 1 over x plus 2 to the 4. So you have division here. This can be rewritten as ln x plus 3 to the ln x minus 1 square root of x minus 1 minus ln x plus 2 to the power of 4. So you have ln x to the 3, you have ln x minus 1 to the square root. This square root is 1 over 2. The exponent is 1 over 2, and exponent is 4. You can put those exponent outside of ln also, outside of logarithm also. You have 3 ln x plus 1 over 2 ln x minus 1 minus 4 ln x plus 2, which is your stretched function. These are the same functions. This is just like the combined form. All the values all the values put into the ln, and this is the stretch form of that function. You are just expanding this function. So that is the result. That is the answer for this question. I believe that will be enough for this session. We have solved about 7 questions in this session. I tried to explain everything in detail. Uh, I hope you enjoyed it. Thank you for listening and watching. Until next time.